Hello, my name is Timur Abdiv.
Hi, I'm Nicholas Timur.
And hello, my name is Isaac Lee.
What we have here is a 3D model of an elevator that allows people to go to 3 stories, 3, 2, and 1.
The way it works is on the outside, it has buttons just like a normal elevator that you can call the elevator to whatever floor you're on. So if the elevator is on the 3rd floor but you're on the 2nd, you can call it and we'll go to the 2nd floor. And it has buttons on the inside just like a normal elevator that will call you to the floor that you want to, that will take you to the floor you want to go to. You go up, you go down, just like a normal elevator.
Perfect. What are the sensors inputs and outputs you're using for this?
So the inputs that we used for this project were these some bumper switches and some line trackers. The bumper switches we used for the buttons to take you up to each floor, so we have one bumper slip for each level to call the elevator, and as well as 2 bumper switches to take you to which level you need to go. The reason for 2 bumper switches is because we had a challenge with the amount of inputs we could use. We were 1 short of 3, so we had to find a way to use 2 different bumper switches to take you to each level, as like for the 1st and 2nd level, but as well as the 3rd level, which we did by when you're at 2nd or 1st level. If you were at the 1st level and you press the 1st button again, you would go to 3rd, and same with the 2nd. You would also go to 3rd if you press it again at that level. We also have the line trackers. There's a line tracker for each level or story. When when it senses that the elevator is at that level and you had pressed the button of the level, you'll stop. So for example, if you press button on level 3 and you're at level 1, you'd go up to 3 and stop when the line tracker senses the elevator.
So the line trackers are there for the system to know where the elevator is at?
Yeah. And
Okay.
then we had 2 outputs, which are just the motors on the back side, which you just, when you press a button, it tells the system how much each motor should rotate until the elevator is sensed. So yeah, it's pretty simple with the inputs.
What are the mechanisms what is this mechanism you're using for moving the object? What is this mechanism?
Yeah, okay, chain drive for each side of the elevator. When a button's pressed and needs to go up or down, simultaneously each chain drive will move up or down, moving the elevator. So if I can demonstrate so let's see, press a button that tells you to go to the 3rd floor, each chain drive will go up like that, and each chain drive is connected to the motors, so it can be done.
Cool, that looks awesome. So can you do one more demonstration for me? Like, I want to see. That's pretty cool.
Down that way.
No, I'm just saying with the buttons.
Yeah. So let's say you're at the 1st floor and you want to go to the 3rd floor, you would press the 1st floor button again, and it would just move up.
All right, and it stops.
Yeah.
Can you call it down? Can you call, what if you mix, go to the 2nd floor for me. All right, looks pretty cool. Cool, so this is the mechanical aspect of the elevator. Can you guys show the code that you guys used to create this? All right, you can turn the screen around.
Alright, so this is all the code we used. These, each of these has 1 left motor and 1 right motor code because they can't run simultaneously in the same started block. And each one of these 6, each 2 of these 6 actually, talks about 1 floor in particular, and the left and right motor that will be driven to it. As you can.
Yeah, so pretty got the basics. So here, if I can zoom into one of these just to have a better idea of what we're talking about. So essentially these 2 are identical except for the motor that will be moved. For example, this this code corresponds to the left motor, and this code corresponds to the right motor, but they are other than that identical in how they both also correspond to level 1, and the different inputs and outputs that are connected to moving the elevator down to level 1. And same with these two codes, but instead it corresponds to taking the elevator to level 2. So
each of them contains the inputs
yeah,
for the elevator bumper and the
motors.
level bumper.
Yeah.
So it's taking, okay.
Yeah.
Which part of it is associated with the line tracker?
Yeah. So the line tracker is used in both hold on. Oh, okay. So the line tracker.
So I can see
Is-
here,
yeah.
the first level 3 line tracker
Yes.
and the level 1 line tracker, are those to see where the elevator is? So like, is that like if elevator?
Yeah.
is that-
Okay. Yeah. So the top part of the code will, these could be switched around. It's just how we put it. But the first part talks about if the elevator is on level 3, and the level 2 bumper is pressed, it will move down to level 2, and it gives like it's like a variable of where it is. And this one is.
And it moves, it waits until it gets to level 2?
Yeah.
Okay.
So it's kind of like just a list of conditions for level 2. Then if it also has instructions for if you're on level 1, and if you press bumper 2, it'll move up to bumper 2 instead of down. So it's a level 2. Sorry.
And just adding on to that, on the actual mechanism, this part right here, I don't know if you can see it from over there, is the part that the line tracker sends.
Oh, this
And-
cardboard part right here?
And this part with the reflectivity of the line tracker, that's coming from here. And sometimes we had to like change it depending on what floor it was on,
Oh,
which was one of the challenges.
oh,
You gotta-
so the 3 line trackers have different sensitivity? Okay, cool.
depending on what position.
That's awesome. So let's first, so what are the big things you learned just in general doing this project? What are some big things you learned, Timur?
I learned basically how a gear train mainly works, and I learned kind of how to, transmit energy to another location really quick and really simply. This actually is, to me, a really realistic model of the elevator in my apartment building. So I kind of learned how it kind of works in my building.
Cool. What about you, Nicholas?
I think you gotta learn from all this. I learned about the mechanisms and like the chain drives and all that. We kind of put all our knowledge we had, we put it all together. I also learned you gotta be patient because we had a lot of like issues with the elevator even at the end, and so you gotta be patient when you go through all that.
Cool. And Isaac?
So I think something I learned was how to like control like multiple different inputs and outputs like at the same time. Like in the past we have done something similar, but I think like at this complexity, it's a different level. And I think like what Nick said with like solving problems as well, just like learning how to like solve how the line tracker detects the elevator, or so just finding different solutions as well.
Cool. And what were some of the biggest challenges that you ran across, and how did you solve them?
So we kind of ran across different problems with the code, including like with motors and stuff. We had a lot of motors busting, running out of power. We had to keep on changing batteries. We had to actually see if there was any like problems with the building itself. So that took a while, kind of. We also had some problems with figuring out how to do reflectivity because it was really confusing. So
Okay, but we
figured it out.
Great. What about you, Nicholas?
I think some of the problems, like Timur said, were with the code, and definitely with the reflectivity, because each one has a different, like, specific reflectivity that you gotta kind of trial and error to figure out. And then we had some problems with, there weren't enough, like, plugs for us to put into the brain of the code. And so we had to kind of improvise on how we could turn 2 bumper switches into 3 bumper switches, basically. And
Cool.
Yeah. So I think one challenge that we actually found like pretty early on was that we didn't know how to operate the 2 gear train. Yeah. Chain drives simultaneously because we couldn't really like put it side by side, but we were eventually able to figure out to have a duplicate of the code. And another one was the code itself. There was just like a whole lot of problems. You know, they talked about the line tracker reflectivity, which we thought was like the opposite. So so that.
Cool.
Yeah.
All right. Thank you, guys.
Thank you.
All right.